You ever mess around with an AI and notice something kind of weird? When it rates code, it's almost always perfect. Well, syntactically perfect anyway. It might not do exactly what you wanted, but the code runs. So, how does an AI that can be so creative and, let's be honest, a little unhinged with human language get the super strict, unforgiving rules of programming so right almost every single time? Well, the answer isn't magic. It's actually more about math. And it tells us a lot about how these things really think. So, let's break it down.
And this whole explainer really kicked off because of this exact question from a developer over on Reddit. And it's such a great observation, right? The AI might just invent a historical fact or totally misread your poem, but you ask it to code something, and it spits out something a compiler will almost always accept. It's a puzzle, but the answer really gets to the heart of how these models actually work.
So that sets up this great mystery, what I'm calling the coder's conundrum. It's really a tale of two completely different languages. You've got the beautiful, messy, creative world of human speech, and then you have the strict, formal, logical universe of code. Why on earth is an AI so much better at one than the other?
Okay, this slide right here, this is basically the whole secret. Think about it. Human language is packed with nuance, sarcasm, slang that changes every week. There are a million ways to say the same thing. But code is the total opposite. It's got a fixed dictionary of keywords and an incredibly rigid grammar. If you type, say, print with parentheses, hello, the chance that the very next thing is world is just ridiculously high. That predictability, that's the key. And there it is. That's our first big aha moment. For a machine whose entire job is to predict the next most likely word or token, the super structured and repetitive nature of code makes it a way, way easier language to master than something like English. It's all just a big game of statistics.
All right, so if we know it's all about probability, how do we actually get the model to be so good at it? Let's peel back the layers of this AI black box and take a look at the training playbook that turns a general language model into a seriously proficient coder. First things first, before an AI can learn a single thing, it has to translate our world into its language, which is the language of numbers. And that process is called tokenization. It just breaks down everything, an essay, a poem, a Python script, into these little pieces called tokens. Each token gets a number. So a simple command like print hello just becomes a sequence of numbers that the model can finally work with. So here's the game plan, simplified into 3 steps. Step 1, the model basically swallows the entire internet's worth of open source code. We're talking about all the public stuff on GitHub, millions of examples of correct, working code. Then comes step 2, its main job, predict the next token, over and over and over again. It learns the patterns, that a def is almost always followed by a function name, that an opening bracket needs a closing one somewhere. Finally, step 3 is fine-tuning, where it's trained on really high-quality code to get even better at following our specific instructions.
And this is so crucial to understand. The model isn't understanding code the way a human developer does. It's not sitting there thinking about logic or your business goals. It is a pattern-matching beast. It has seen so much code that it has this near-perfect statistical map of how code is supposed to look and feel. And this incredible knack for pattern matching leads to some seriously powerful stuff. We're moving way beyond just getting the syntax right. Now we're talking about generating entire, complex solutions from just a simple, plain English request.
So, how does this actually play out? Well, here's a real-world prompt given to GPT-4. And notice, this is not a simple hello world. It's a multi-step task. It has to deal with the file system, it has to read files, it has to parse HTML. This is complex. So what happens?
The model doesn't just give back a little code snippet. Nope. It gives you the entire working script. It explains what each part of the code does, and it even tells you which libraries you need to install to get it working. I mean, this just shows how far these things have come. They're not just fancy autocompletes anymore. They're more like a junior developer you can partner with.
And these skills are being plugged in everywhere. We're seeing it used for automatically routing support tickets, analyzing customer feedback for sentiment, even detecting potential bugs in a system before they become a real problem. The ability to speak code is having this massive ripple effect across the whole business world. But, and this is a huge but, this is where we need to pump the brakes a little. The AI's mastery of syntax is incredible, but it can hide some very serious problems. You could say there are ghosts in this machine, and just because the code runs without an error, that does not mean it's correct or even safe. And this is the question every single person using these tools needs to be asking. The AI just handed you this beautiful piece of code. It ran on the first try. Amazing. But did you actually check the logic? Did you stop and think about the security risks? Here is a perfect example of what's known as a hallucination. You ask the model to do something that is mathematically impossible. You can't add two even numbers to get an odd number. The model doesn't say, hey, that's impossible. Nope, it just confidently writes a perfectly valid function that returns a completely wrong answer. The code runs, but the logic is fundamentally broken.
Okay, this next one is even scarier. You ask for a simple script, the model generates it, but it completely forgets to check or sanitize the user's input. This creates a gigantic security hole. A bad actor could input a command that completely wipes your server. The AI, just focused on pattern matching to fulfill your request, has accidentally created a weapon.
And look, these are not just some theoretical problems I'm dreaming up. The risks are so real and so significant that the security community has already responded. They've created a special guide, the OWASP Top 10, that's the Open Web Application Security Project, and it's specifically for the new vulnerabilities introduced by these large language models. And this table really shows the new kinds of attacks we're all dealing with now. You've got things like prompt injection, where an attacker literally talks the model into breaking its own safety rules, or insecure output, which is exactly what we saw in the last slide. So developers now have to worry about not just traditional security, but securing the AI itself. Which brings us to what is probably the single most important takeaway from this entire thing. AI-generated code is an amazing tool. It's a fantastic productivity booster. But you must always treat it as a first draft. It is a starting point that needs to be reviewed, tested, and secured by a human who actually understands the context and the consequences. So we end up right back where we started, but now with a totally new perspective. The AI's ability to master the rigid world of code isn't magic at all. It's just proof of its incredible power as a pattern-matching engine. And that leaves us with a pretty fascinating and maybe a little unsettling final question. Now that it's conquered the strict, predictable logic of machines, what kind of complex human logic is it going to master next?